So hashing is one of the most important data structures where it provides us an efficient and unique way to store the data. It also helps us to store the data, to search the data, delete the data, and modify the data. So far, we have already used binary search tree for a more efficient way to search an item that takes almost big O of log n of time complexity. But we can also reduce down it to constant time complexity, which is big O of 1, with the help of hash table and hashing techniques. But even in hash tables also, the worst case scenario is big O of n, but for average case we can reduce it down to big O of 1 or constant time complexity. So that's the advantage of hashing. So in hashing there are mainly three things which participate in the process of hashing. One is the key, one is the hash function, and the third one is the hash table. So we will go step by step in details. What is a hash function? How does it work? What is the structure of the hash tables? And what kind of data structure do we need to implement the hash table? So we will see those things in details in next couple of lectures. By the way, to implement hash table, we need the concepts of objects inside array, or you can say associative array, or you can say array of arrays, or we can also implement hash table with the help of linked list and arrays combined. So we will see those things in the next couple of lectures. So stay tuned. Okay, so let's understand how hashing works in a little bit more details. So basically hashing is nothing but to store our data in a very different, unique and much more advanced way, so that we can insert the data, we can access the data, we can update the data, we can remove the data, and also we can modify the data in much faster way compared to any other pre-existing data structures. For example, binary search trees or normal searching and sorting methods. So what actually happens in hashing? So in hashing, we have three elements, as I have already mentioned. One is the key. Okay, so we are actually storing this key. What is a key? A key is nothing but a data. It's a data which can be a number, which can be a string, okay, or it can be anything else. Okay. The second thing is we need a hash function. Okay. So what is a hash function? It is a function. So we are going to write the code in JavaScript. So it's a JavaScript function that takes as an input this key. Okay. So this is the, you can say, if I say this is a hash function. So our key, which is nothing but the data, which is a number or a string or something else. So that key is the input to the hash function, and this hash function generates index. Okay. So index is a unique integer number. Okay. The third one is based on this index, we now need to store the key. So we inserted the key, that is the input to a hash function, and we got the index as an output. Now, so we have two things. We already know the key and we also know the corresponding index. Now what are we going to do with these two? We need to store the key. So where are we going to store? We need to store that in something called a hash table. Okay. So this is a hash table. So generally the hash table can be implemented in multiple different ways. Okay. So we need to store the key based on the index in a hash table. So hash tables can be implemented in multiple different ways. One is a easy way. Easy way is a hash table consists of buckets. So slots, these slots are called buckets. Okay. What are these buckets? These buckets are nothing but, in a simple way, if I say, these are key value pairs. So this is one bucket.
This is one bucket. Okay, this is one bucket. So there are, you can see there are three buckets, let's say, in the hash table. So hash table is a array of buckets. That's what a hash table is. Now what are each bucket? Each bucket, if we are implementing in a simple way, then each bucket is nothing but a key value pair. Okay. So what is the key? The key is the key that we gave as an input to the hash function. And what we got? We got an index number. What are the index? The index is the index of these buckets. So let's say the indexing starts from 0 because it's an array of buckets and array elements are indexed, right? So 0, 1, 2. So this hash function generates the index of this buckets. So if this key, let's say the key value was ABC, for example, and this key is generating is 0, 2, then this key of a value ABC will be placed in the bucket, the index of which is 0, 2. So ABC will be placed here. So let's place ABC here. So it will directly come here, ABC. So this is the key, and along with it, we can also store some extra value. Let's say we are storing employee data, and this is the employee ID. ABC is the employee ID. So we can store its name, phone number, salary, whatever. Let's say salary is $2,000. So along with the key, you can also store the value. So that is the simpler way of inserting value or storing value into the hash table, where hash table is the array of buckets and each bucket contains only one single key value pair. Now, why we have implemented hash table in this way? So there is a bigger reason behind it. We will talk about that later. But there is another way also we can implement the hash table. So there is another way to implement hash table. So again, we can say hash table, it is a array of buckets. Okay, so it's like an array and it has buckets. So previously we stored only one key value pair in each bucket, but that is a simpler way of implementing hash table. A more advanced way of implementing hash table using linked list or array of objects or associative array or array of array is storing multiple key value pairs. So you can give like key value, then again key value. So it can be, each bucket itself can be array of key value pairs. Okay, so in this way it can have at least one, it can have more than one. It depends how you are getting the data and how you are storing it. Okay, but why do we need two different approach to implement hash table? So the reason we will discuss in the next video. So thanks for watching. See you in the next video. Okay, so I think we have already discussed about how the hashing works. So let's understand the process of hashing with this animation. As you can see, we have a key and the value of the key is ABC. So let's start our video. So you can see that this is our key. The key is basically nothing but some data. It can be a string or a number or whatever. So what happens is this hash function, it takes this key as an input and it gives a index. So let's imagine hypothetically that for this particular string input, we get an index. The value of the index is 3. Now, how we get index 3, that's a different question. We will explain it later. But this is the function that takes this key as an input which is ABC, and it returns an index. The value of the index is 3. So next what? So now you can see that there is a hash table. Okay, so hash table is a array of buckets, and each bucket is a key value pair at its simplest form. Okay, so each bucket can have one key value, it can have multiple key value pairs. So for now, let's imagine each bucket has a one key value. So you can say the bucket index. So there are 4 buckets, 1, 2, 3, 4. So where will this particular key will go? Where will ABC will go? ABC will go to the third bucket, right? So that's where we will have our key and corresponding some extra value if we have it. So that's what the entire concept of hashing is. Okay, so hopefully you got an idea, and we'll see you in the next video. Okay, so what we have just now seen is, if we have a key, okay, we pass this key as an input parameter to the hash function. A hash function is a function which takes the key as an input parameter, and it returns or generates or produces an index. What is the index? The index is the index of the buckets inside which this key will be placed along with some value, right? If we consider the simpler approach or the complex approach, for both, these are buckets, right? They have indexes like 0, 1, 2. So this key is generating an index. So if it is generating, let's say, an index number of 0, 2, then this key will go to the third bucket. So here this key will be placed along with some value. So that is the concept of hashing. Now, what is a hash function, and how does the hash function work, and how does it generate a number? So generally, a hash function can be implemented in many different ways based on the complexity. So a very simple approach of generating hash function is, let's say we have ABC as a key. So what we are going to do, we will take the ASCII of A plus ASCII code of B and ASCII code of C, and whatever the total is, so I have just calculated, it is coming out to be 294. So this is 294, and then what you do is, let's say in actual program we have, let's say, 10 buckets. So the length of the hash table is 10. So let's say the length of hash table is equals to 10. So what we are going to do, we will find out the modulo. So the ASCII of the key, and divide it actually by the length of the hash table, and we will try to find out the modulo. So in this case, what will happen, this is 294 and we are getting a modulo 10, so we will get 4, right? So in this case, ABC will be placed in the fourth bucket. Okay, ABC will be placed in the fourth bucket. But let's say there is another key, the value of which is DNX. Now, if you also calculate the total key ASCII code value of DNX, it is coming out to be 68 plus 78 plus 88. So it is 234. Okay. Now again, 234 modulo 10 is also 4. So for DNX also, I am getting a index number 4. For ABC also, I got an index number 4. For DNX also, I got an index number 4. Now, Can I place dnx in the fourth column? No, because it is already occupied. So this situation where two key, okay, let's redraw it in a little bit better way. So when two key values, okay, one is abc and one is dnx, okay, they both are going through the hash function, and the hash function is returning an index value of 4 for both of them. So we cannot allocate both on the same bucket, right? So that situation is called a collision. When there is a same index number generated for two different key inputs, the situation is called a collision. Okay. So how can we handle the collision? So we have already seen that our hash table can be implemented in two different ways. In the first easier way is you have n number of buckets and each buckets contain a single key value pair, right? So this has a key value, this has a key value, it has a key value, this has a key value, this has a key value, right? So what we got, let's say 0 1 2 3 4. So we are getting four index value for both abc and for both d and x, but we can only accommodate abc here because it can take only one value. So what will happen for d and x? So there are two different way we can handle collision. One is called linear probing. So linear probing is used when we have implemented hash table in this simple way, like one bucket contains only one value. In that case, what we will do, so we have found out that the index for dnx is 4, but 4 is already occupied. So we will search for the next available bucket. So we have total 10 buckets, right? So now here we have already 5, 1 2 3 4 5. So another 5 we have. So we will search for the next free bucket. Okay. So let's say the next one is occupied, but the sixth one is free. So we will put dnx on the sixth one. So whatever the next free available bucket, we will put our key into that bucket. That is called linear probing. But what will happen when our hash table is implemented in such a way that the bucket can store multiple key value pairs, right? So it can have one key value, then another key value, then another key value. Okay. Now, if we have two separate key which is generating same index, abc and dnx, right? So in that case, what we will do, we will search, okay, see, this key value pairs are in the same bucket. So for abc, whatever the value, we will just update that value. Okay. And if it is a different key, we will add it at the end. Okay. On the same bucket. So if it is generating the same index, and if the key already exists, so we will update the value, and the key does not exist, we will add the key at the end. So that is called separate chaining. Separate chaining. Okay. So separate chaining is always a better approach to solve the collision problems, and therefore this is a better way to implement the hash table where each bucket can store multiple key value pairs. So we will see how to handle both the collisions with the help of JavaScript and array of arrays. So see you in the next part of the video. Thank you very much. Okay, so far we have understood the concept of hashing, and we have seen that there are two types of hashing techniques are available when collision occurs. So one is linear probing. And linear probing is used when we have a hash table which is nothing but an array of buckets, and in each bucket we can store a single key value pair. So if we implement the hash table in this way, then the only way we can handle the collision is linear probing. Okay, so each implementation is done because there is a chances of collisions, so we want to handle the collision. That's why each implementation is done in a particular way. Now if we have an array of buckets where each bucket itself can contain multiple key value pairs, okay, like that, then what will happen? Then this way of handling collision is called separate chaining. So what happens in separate chaining? Let's say this is bucket 1, so its index is 0, bucket 2 index is 1, bucket 3 index is 2, whatever, and our hash function for a particular, let's say, input, it is generating an index, and the index value is, let's say, it is 2. So this is our key, right? And this is the index value is 2. So what it will come to the this bucket with this index value 2, and it will try to insert this value a b c and with some value. Okay, but if this particular key with some value already is there in that bucket, then it cannot create a duplicate key value pair. That is not allowed. So what it will do, it will update the value with the latest value. Okay, the latest value, so which is in this key and corresponding value, so that value will be inserted. But if this particular key is not there, then it will be added at the end. Okay, so this is a more advanced way of handling collision rather than writing the code in linear probing. So in the document that I have attached here, you will get 3 different implementations. One is for handling collision with linear probing. Okay, so in that case it's a simpler approach. Another way is to handle collision with separate chaining. This is called separate chaining. Okay, it's a chain of key value pairs, so we are handling with separate chaining. And another one is we can connect them with the help of a linked list. So each of the key value pairs are like a node, and they are connected with each other in the form of a linked list. So linked list implementation is also there, so you can use whatever feels good for you, but I am going to implement with the separate chaining with the array, and inside array it can be objects, it can be array, it can be associative array. So let's understand those structures now. Okay, so there are 3 different things. One is associative array. Okay, associative array means it's like a collection. So it looks like an object, and then you have key value pair. Let's say a and 1, then b and 2, okay, and c and 3. So this kind of structure is called associative array. It's not an array, it's like a collection. It's a collection of key value pairs. It's a collection of key value pair, which is called an associative array. The second one is array of objects. Okay, so it's like an array, and inside that you can have objects, which are different elements of the array. So in each object you have key value pairs. Okay, so name, x, something like that. And the third one is array of array. Okay, array of array. So it's a 2-dimensional array inside array. Okay, so which is like array, then inside the main array there are small array elements. Okay, so we will use the third approach. Okay, so let's explain these three different structures with the help of coding. First, let's understand. So once I say that it is an associative array, so let's try to understand what is an associative array is. Okay, so let's say each bucket, let bucket equals to, if I write Alice, okay, and then if I say 1, then Tom, if I say 2, and John, if I say 3. So this structure, this is called an associative array. So we can call it associative array. And how can I access the values? Because there is no index. So for that, what I need to write, bucket of, okay, then we can give value. You can use either of them. If you give John, and then if you run this code, okay, so it will give you 3. So because John has a value of 3. So this is one way to implement the bucket using associative array. Another one is, array of objects. So let's say bucket 2 equals to, it's an array of objects. So each object has a key, right? And the value is France, and then it can also have a value, and the value is, let's say, 100. Similarly, it can have another key with value Grace and value 200. So now if I want to access, so what I'll do, it's an array. So each of them are array elements, which is an object. So I will say bucket 2. The first one is a 0. So 0th one dot key. So if I give the key, I will get, France. So this is how also you can implement a bucket. But the best way is using array of array. So it will make the code much more simpler. So let's say bucket 3. So we can create array of array. So you have already know what is an array of array. Is a fundamental JavaScript. So in each array we have values like this. In the sub array, in the internal arrays, we have values, and then can have, let's say, Spain, and then 200. So how do you access them? Simple array. So it's like bucket 3 0 of 0 and bucket 3 0 of 1. So what this is going to give? This is going to give France, and this is going to give 100. So France and 100, right? So it's a 2-dimensional. Now another thing is that you can use a linked list as well. So for that you need to create a, for that you need to use a object rendered concept, and then you create a node. So in each node we have a constructor, and then key and value, and then this dot key equals to key, and this dot value equals to value, and this dot next equals to null. So it basically kind of looks like that each node, right, they look like this. This is the key and value, and this is the link. So this is how they are connected: key, value, and node. Okay, and the last one is null. So it's a singly linked list, you can say. It doesn't have a like left and right pointer. it's have data in pointer. You can also use doubly linked list, it's up to you, but that's fine. The way we are going to implement is we will be using array of array. So let's see how we can do that. So let's start writing the code. So what we are going to do, we'll create class and we write it hash table, and in the hash table, what do we have? We will have a constructor. So we are basically implementing the hash table. The hash table has a constructor, and in the constructor we have this dot table. So what is a table? A table is an array, right? It is an array, and let's say I give a number 127. Why did I give a 127 number? Because it's a prime number, and it will help to create different indexes every time, because it's a not a very big number, it's a very not a very small number. So generally if we use prime number to divide something and to get the module out of it, so it is better to use this. It's like after a lot of trial and error and research, it is decided that it is better to use this number 127. So it minimizes the creation of same index. Okay, so it has been seen that it behaves like that. Then this dot size, what is this dot size now? This dot size is actually, if we go back to the picture again, this dot size is actually the total number of key value pairs in this entire table. This dot size does not mean row into column, or this dot size does not mean the total number of buckets. This dot size means the total key value pairs in the entire table. So the moment we will add a new key value pair, we will increase the value by 1 of size. So initially I'm keeping it 0. Okay, and the array size is 127, means it has 127 buckets. It has 127 buckets, right? Now what is next? So we need to have a hash function. So we will write is an underscore hash, and it takes the key as an input. Now what it is going to do? So let's say I have a variable hash, and that is initialized with 0, and for let I equals to 0, I is less than key dot length. Okay, we discussed about it. How do we get the ASCII value? So the summation of ASCII of each character. So what do? We use plus equals to operator, and then key dot char code at char code at I. Okay, and what it will do, once I get the total summation of all the ASCII code, then what I will return? I'll return index. What is the index? Index will be hash percentage, means modulo of this dot table dot length, means 127. So we are dividing it by 127. So that is the hash function. So this is the total number of buckets. This is the total number of key value pairs. Okay. Total number of key value pairs in the hash table. This is the hash function, right? And then what is happening inside the hash function? Whatever the key, we are summing the ASCII code of each of the characters, and then we are dividing it by the total number of buckets, and that is returning me an index. Now what I'm going to do? Now I'm going to insert, right? So for that I give the method name as set key value. So I'm going to insert the key into that particular bucket. So what I'm going to do, let's say constant index equals to, okay, this dot hash of key. So calling the hash function, passing the key, we get the index. And if this dot table dot index, then what we are going to do, so for let I equals to 0, okay, I is less than this dot table index dot length, means we are checking a particular bucket. What is that bucket? The index of the bucket we have already got from the hash function. Now in the entire bucket we are checking, okay. So if this dot table index, okay, I of 0, so obviously in the 0th position we have the key value. So if it matches the key, then what we are going to do, we will update with the more updated value. So this dot table, because we cannot keep two same key value pairs, so the existing keys value part will be updated, will be value, right? So we'll update the value once the key is found, and then we will stop. So return nothing. And if the key is not found, then what we are going to do, this dot table, so we'll add a new key value pair at the end, dot push, okay. Else, if the bucket itself is not there, if that index is not there, then what we are going to do, we'll create an empty bucket, this dot table and then we will insert this dot table of index dot push key value, okay. So where is the if statement? There has to be an if for else. So I actually have written wrong. This is if and this is the else. Looks like it's perfect now. And once that is done, so what I'm going to do, I will increase the size of the table. This dot size, not the size of the table, size of the total key value pairs, because we have inserted one, because initially this dot size was 0, right? So that's all about the insertion. Now the rest is easy, which is once you have inserted, now we are fetching. So for get, you have the key, and again you find the index, this dot hash, and if this dot table index, then again you write a for loop for let I equals to 0 and I is less than this dot table of index dot length I plus plus, and if this dot table of index I 0 equals to key, then we need to return this dot table. We have to return this dot table index I. So if it finds the value in a particular index, it will just return it. That's it. As simple as that. Now the next one, if it does not find it, so it will return undefined. Okay. The next thing is the remove key, the remove method. The next one is the remove method. Okay. So in the remove method also, we will pass the key and same thing, index equals to uh, this dot underscore. I think I made a mistake in the previous one. It is this dot underscore hash because our method is underscore hash. So here also this dot underscore hash, because as you can see this is underscore hash, right? So we made that mistake. This dot hash key, okay, and then if this dot table of index and this dot table index dot length. Okay, so what we are going to do, for let I equals to 0, we are running a for loop and I is less than this dot table of index dot length I plus plus. So we are looping through the bucket, and then if this it finds the element index I 0, I mean it finds the key basically. If it finds the key, it will use the splice method to remove. So splice is a very good way to remove elements from the array. So splice method is used to remove an element. So in this case we are using array of array, so each bucket is an array. So it, in that bucket, it will remove that particular key value pair. Okay, so then after that we will have this dot size minus minus and return true. Okay, or else you can give return false. So we are done with this remove. Now the last one is display method. Nothing, we just have to look through and display. So this dot table dot for each values indexes, and it's an arrow function, and if values, then what we are going to do, constant chained values. We are creating a variable called chained values equals to values dot map. So we will display everything with the help of the map method. So it will be key value and then we can display with the help of console.log. and write dollar index dollar chain values dot join. Okay, so this is how you can display it. Now let's create an object. So constant hash table equals to new hash table, and let's use the set method. So ht.set France Spain Germany. Okay, now what I'm going to do, ht dot and then we have console.log ht dot size and ht dot remove. Let's say I want to remove Spain, and then ht dot display. So that's it. That's all our code is. Okay, so I made a mistake here, typo. So it is an arrow function. So now if I run this, my code is working fine. So I have inserted 3. Now it is showing 3. After that I deleted. It is showing me the total count, and after deleting Spain, it is only showing France and Germany. So hopefully you have got an idea how the hash functionality works. And so that's all. See you in the next video with the graphs and other things. Thanks for watching. Bye bye.